Welcome to the Deep Dive. Today, we're kicking off something pretty ambitious, I think. We're looking at Islamic theology and connecting it to the philosophy of science.
Yeah, it's a big undertaking. The sources we're using are really trying to lay the groundwork for a much larger historical look at how Orthodox Islamic theology interacted with science over time.
But before jumping into history, we need to get our terms straight. That's today's goal.
Exactly. And this is aimed at, well, a couple of groups. It's for Muslims maybe needing a refresher on some philosophical basics, but also for anyone interested in science, physics, who might not know the theological side. We're trying to be conversational, even with this dense stuff.
So our mission for you listening is basically this. Let's pull out the essential philosophical and scientific ideas, the vocabulary, the kind of integrity needed before we dive into the historical narrative, like setting up the chessboard, maybe.
Good analogy. And the very first piece we need to place carefully is theology itself, because how it's used here isn't quite the standard Western definition.
Right. So in Islam, how is religion structured? I know there's a key hadith, a saying of the Prophet, that breaks it down.
That's the one. It outlines three main components. First, there's Iman, which is also called Aqidah. This is your creed, your doctrine, your beliefs.
Okay, so that's the theology part we're focusing on. Belief in God, Day of Judgment, all that.
Precisely. Iman is the core subject for a deep dive. Then second, you have fiqh. That's the Islamic law, the Sharia, how you actually practice the beliefs.
Got it. Beliefs, then practices. What's the third?
The third is ihsan, often associated with tasawwuf or Sufism. This is about spirituality, sincerity, striving for excellence in faith. So Iman, fiqh, ihsan, belief, law, spirituality. Our focus is firmly on Iman.
And that Iman part, the theology, it can function like a type of philosophy when you start analyzing it, relating it to broader philosophical questions.
Absolutely.
Let's get the basic philosophical toolkit ready. The three classical branches, starting with the big one, metaphysics.
Right. Metaphysics, it's about the fundamental nature of reality. What is there? What's it like? The really basic questions.
And the name itself, metaphysics, it's got a funny origin story, doesn't it? Not quite what it sounds like.
Yeah, it's often thought to mean beyond the physical, but originally it was just, well, practical librarianship. It comes from the Greek Metaphysica Biblia, meaning the books that came after Aristotle's books on physics in the library collection.
Just a shelf label, essentially.
Right. Pretty much. An editor, Andronicus of Rhodes, cataloged them that way. Of course, later philosophers ran with the beyond the physical meaning, but that wasn't the start.
Okay. And inside metaphysics, there's a core branch.
Ontology. That's the study of being itself. What kinds of things exist? How do they exist? How do they relate? This becomes super important when Islamic philosophers start questioning Greek ideas about, say, necessary existence.
You need to agree on what exists before you can debate why it exists. Makes sense.
And the third branch, absolutely vital for science, is epistemology.
The study of knowledge. How do we know we know?
Yes. What counts as knowledge? How do we get it? What are its limits? You can't do science or even critique theology rigorously without tackling epistemology. Metaphysics, ontology, epistemology, that's the framework.
So we've got the theological view, the philosophical language. Now, the source talks about the conditions needed for science to even happen in a society. It's not just about having smart ideas, right?
Not at all. There are crucial external factors. You need basic security, law, and order. Science doesn't flourish in chaos. You also ideally need a lack of political interference dictating conclusions.
And money, presumably. Research isn't cheap.
Definitely. Economic stability, funding sources that allow for long-term projects without demanding instant results. And socially, you need a culture that values critical thinking, that doesn't just go for the easy answers.
That seems like a high bar. But even if you have all that, the source brings up another prerequisite, an internal one. Richard Feynman's idea.
Ah, yes. Cargo cult science. A brilliant and pretty cutting observation Feynman made back in '74.
What exactly is it?
It's when you mimic the form of science but lack the substance. You go through all the motions, the experiments, the papers, the procedures, but you're missing the absolute core ingredient. Scientific integrity. Utter honesty.
The analogy he used is quite vivid.
It is. It's based on South Pacific Islanders during World War II. They saw planes land on airstrips bringing amazing goods cargo. After the war, wanting the cargo back, they built replica airstrips out of bamboo, lit fires alongside them, even made wooden headphones, and sat in mock control towers.
They copied everything they saw the servicemen do.
Perfectly copied the rituals. But, as Feynman said, the planes don't land because they didn't understand the underlying principles. In science, the cargo cult version follows the methods but lacks the principle of utter honesty, bending over backwards to check if you might be wrong, reporting everything, especially the inconvenient results.
So it's about not fooling yourself, first and foremost.
That's what Feynman stressed. You're the easiest person to fool. So cargo cult science is going through the motions without that rigorous self-skepticism and transparency.
That internal honesty seems essential to protect the actual tools of science, which brings us to those core methods. Let's start with empiricism.
Okay. Empiricism is fundamental. It's the idea that knowledge comes primarily from sensory experience, relying on evidence that is observable, measurable. This gives you a posteriori knowledge after experience.
Without that, no physical science.
Pretty much. Then you have the two main ways of reasoning, deduction and induction.
Deduction is starting general and going specific.
Right. Reasoning from established premises or principles to a logically necessary conclusion, like in maths or logic. Often gives you a priori knowledge known before experience.
And induction.
That's the other way around. You observe specific instances, lots of data points, and you try to form a general rule or theory from them. That's how most scientific laws are developed, from particulars to universals.
Okay. We also need to touch on skepticism, but the source makes a distinction, right?
Yes, a crucial one.
Yeah.
We're talking about scientific skepticism, which is a practical approach. It means questioning claims that lack solid empirical evidence or aren't reproducible. It demands proof. It's not the same as deep philosophical skepticism that might doubt everything.
It's a tool, not a worldview.
Well put. And finally, the mechanism that tries to keep the whole system honest. Peer review.
The gatekeeper.
Ideally, yes. It's the process where experts in a field evaluate submitted work before publication. It's meant to check for validity, significance, originality, maintain standards, catch errors. Basically, enforce that Feynman-level integrity, at least in theory.
Right. So quite a bit of ground covered there. We've defined theology in the Islamic context, focusing on Iman, the creed. We've linked it to philosophy via metaphysics and ontology.
And we've looked at the necessary conditions for science, the external societal ones, and that critical internal integrity, avoiding the cargo cult trap. Plus, the core methods: empiricism, deduction, induction, skepticism, peer review.
It feels like we've really laid the foundation now.
I think so. And it's all necessary because, as you said, the source material jumps right into the history of Islamic philosophy next. These concepts are the lens through which that history will be viewed and analyzed.
So here's something to chew on as you leave this discussion. How much of our modern science, our research, our intellectual debates truly lives up to Feynman's standard of utter honesty? Or are we sometimes maybe just building really impressive-looking runways, going through the motions, hoping the cargo of real understanding will just land? That's the challenge these foundations pose.